Hello, my name is Roshan Matthew and I'm from NGIT group number G416. My project is JoyVerse, which is a real-time emotion detection. JoyVerse is a dynamic web platform that interprets human emotions in a real time through facial expression analysis. Utilizing a webcam, it captures live input images and detects emotions like joy, sadness, surprise, and others. The system is designed to develop emotional responses, interactions, blending facial recognition to technology with intuitive user experience to foster more engaging and emotionally intelligent digital environment. The major learnings from this implementation are the full stack interaction, the API calls and handlings, how the image data has been processed, the model integration, debugging and deployment, and the user experience focus. Milestone achievement confirmation. So the core goal have been met in this milestone. The primary objective of an interactive emotion detection has been successfully achieved. Real-time input, the webcam captures and processes real-time video efficiently. Reliable detection, emotions are detected accurately using a robust and reliable model. Dynamic front end dynamically responds and updates based on the detection emotional states. And the smooth integration, which seamless integration across the entire techno, technological stack ensures field operations, and the MVP operationals. Model selection, that is the transformer. The key reasons for using a transformer is because it is specialized trained. We have used a pre-trained the model is pre-trained on the FER plus data set, making it highly suitable for facial emotion recognition tasks. The API output offers an easy to integrate API with compatible structured output formats, simplifying backend processing. Performance, it achieves high accuracy with low response time, making it well suited for real-time emotion detection in the interactive application. Efficiency is very good. It requires no additional training, helps us save efficient deployment time and computational resources. Scalability can be easily extended to recognize additional emotions or integrate it into more advanced pipelines if needed in future updates. And it's very reliable, consistent performance across varied lightings and facial orientation. Transformer advantage, it uses self-attention mechanism which outperforms traditional CNNs in capturing spatial features across the face more efficiently. So the models which we have considered but have not used were the FUR Plus, which considered but deemed slightly outdated and lacking comprehensive documentation. Custom CNN requires significant training time and computational resource, not feasible for project timeline. OpenCV plus classical offers a lower accurate compared to modern deep learning models for emotion detection, and the multimodal models not necessary as a use case focuses solely on facial emotion, not text or other inputs. So the chosen module, that's the transformer, offer the optimal balance of performance, accuracy, and easy integration of JoyVerse. So the architecture diagram changes from milestone 1 to milestone 2. Milestone 1 is the left, and the difference, the change what we have done is that in the updated architecture, the key improvements were made to enhance both performance and scalability. The previous architecture diagram used Flask as a backend, which now has been replaced with Fast API, which offers superior asynchronous capabilities and quicker response time for processing input images and analyzing game states. Emotion detection recognition was upgraded to use a transformer model, moving away from earlier clip and GPTML setups, resulting in better accuracy and faster predictions. The Node.js middleware still handles API routings, but now interfaces more efficiently with the fast API services. The MongoDB Atlas continues to serve as the cloud-hosted database solution, efficiently storing user records, emotional data, therapist-related information. These architectural updates have led to a more streamlined, scalable, and maintainable system overall. The challenges and hurdles which we have faced during this period of time were the model integration, which connecting the transformer model to the fast API backend and ensure reliable interaction with the Node.js middleware took more time than initially planned. Cross-stack communication, that is facilitating seamless data exchange between the JavaScript based Express and Python based fast API requires precise handling of API structure and standardized error handling. Then there's the real-time webcam processing, ensuring a consistent and efficient capture of live webcam frames in the browser. and transmitting them accurately to the backend, presenting performance and reliable issues. The MongoDB schema structure. Designing a flexible schema in the MongoDB atlas to accommodate both gameplay data and the therapist reports required careful planning to balance structure with adaptability. And then there's a complex deployment workflow, deploying all major components, that is the front end, middleware, and back end models, and the cloud database into a coordinated way for production demanded several rounds of setup, debugging, and optimization. Limited full stack reference. Due to the hybrid stack, there was a lack of full end-to-end examples, forcing the deployment of custom solutions throughout the project. Okay. The deployments, that is the front end and the middleware hosting. The front end is deployed as a static website, making it compatible with local environments of cloud platforms like Vercel. The middleware built using Node.js and Express operates either locally or on deployment servers such as Render or Railway. Mm, Model interference, instead of you running the model locally, interfaces performed through a fast API based backend. This separation eliminates the need for direct local deployment of the model. This simplified setup greatly reduces the infrastructure overhead, allowing faster deployment and easier scalability with the flexibility to move to a dedicated backend server when required. These are a few code snippets of my work of our working project. This one is the child registering API endpoint, basically how registering the child into the API to the endpoints. We are even verifying it using the Thunder client on the right side. Basically, creation of the child's account into the project, into the game. So this is another one. This is the login page where you can either check for child or therapist. We are to notice whether if the particular account exists or not. This is a code snippet of it, and we are right side is the way we are verifying it using a Thunder client just to see whether the content works or not. If it is, it says login successfully. If not, it says login failed or user doesn't exist. The demo. Hello, so this is the login page, this is the welcome page of our project, of our JoyVerse. So let's get started. So this is the area where you can get to create the email of the therapist and the child account. So this is where the child account is being created. So okay, for now let's create a child account. Let's give the name as Rohan. Wait, R Rohan. Age 11, and email rohan@gmail.com. And parent can be anything, parent@gmail.com. Password, yeah. So now once you're done, it redirects you into the child's login page. So this is how the child login page looks like for now. So let me just show you, or let me show you the super admin page, that is this one, where I can see the therapist, the accounts, where I can see verify the accounts. If not, I can even create them or I can delete them. And this is where we have created Rohan. As you can see, we have created the child account over here. We can remove and delete. So let's delete this account. So now once we deleted the account cannot be accessible. So let's log into another account, which is the Ishan Avasti, which I have created as a child. So let's log into it. So yeah, this is the dashboard. This is where the game stats of the child have played all the games. The game scores have been stored over there to display them. So let's play this missing letter pop game. This is how the missing letter pop game looks like. Let's start the game. Okay, the emotion has been detected as surprise ping. Mm, yeah. Mm, yeah. So there's a time limit. As the time limit progresses, the game finishes. So now that's the missing letter pop, and let me show you a different game. That's a spaceman game. The spaceman game looks like this. Start quiz and you get to play the game. Correct answer, yeah. If there's a wrong answer, there's a pop-up and the emotion changes based on, yeah. So next is the Pac-Man quest. This is a Pac-Man colored game. This is another game which we have implemented. Basically, you gotta choose the correct target color. You have to keep going, choosing the target color. All right. And these two, the art and drawing and music fun activity and music fun, these two are fun activities which the child can get to play and, you know, have some fun over there. Let me show you. This is the music and fun. Now let me show you the therapist dashboard. So this is the therapist dashboard where he can check the game performance and the support level distribution. He can even check the emotion status of the particular child, and he can even add some notes on based on this child if there's anything description which he wants to give. So yeah, that's it. Yeah. So thank you.